Okay, so electrical troubleshooting. So the first place that you're always going to want to look whenever you're having an apparent electrical issue, whether it's something not turning on, you're getting an error notification from your GX touchscreen, or you're just trying to understand an inherent electrical problem in your van, the first thing you're always going to want to check, just like when you're having an electrical problem at home, is your breaker and your fuse panel. So most of the breaker panels and fuse panels that we have are either installed at the rear of the van or they're facing aisle on the high box installations or the Murphy bed installations. They'll be in one of these two locations, here at the rear or aisle facing. The breaker panel and the fuses themselves are all accessed behind this black plastic cover. You'll just go ahead and peel that cover off. And all of the DC circuits are powered, or they use fuses. They're just standard automotive blade fuses. The fuses themselves can be a little difficult to pop out, but to check a fuse, you'll just pull it out of its slot, and then there's a little wire on the inside of the fuse itself, and you want to make sure that that wire is intact. If you see that that wire on the inside is burnt up or it's broken, then that means you've blown a fuse. These are pretty easy to come by. You can get them from pretty much any automotive parts store, hardware stores. I mean, even some supermarkets and grocery stores in their automotive section carry these as well. It is a good idea to go ahead and buy a pack of them as a backup. Now, once you're done checking the fuse, or if you need to replace it, all you're gonna do is just go ahead and shove it back into place. If it's a switched circuit, you'll wanna make sure that you turn the switch back to the on position. If it's not a switched circuit, you should notice that the unit automatically kicks itself back on as soon as you plug the fuse in. So that's fuses. That's all of your DC loads, once again, in the van. So things like your refrigerator, your lights, your water pump, the basics, the USB outlets, things like that. The 120 volt or 110 volt, however you like to think about it, appliances that are in your van that need your inverter to be on for, they're all powered by circuit breakers. And those circuit breakers are standard circuit breakers that you find just like in your home. Some of them are standard breakers, or they are GFCI circuit breakers. Now, this panel isn't necessarily labeled because it's still under construction, but typically you'll see all of your circuits for both DC and AC labeled here. So if for whatever reason your electric heating element on your heater isn't working, there will be a dedicated breaker for that. A blown breaker will typically be in a middle toggled position, and you'll have to turn it to the off position and then back to the on position in order to get it to turn back on, especially for the GFCI breakers. So if any of these are in the off position, that's usually the first indication as to why that specific appliance isn't working. A broken or a turned off circuit breaker isn't necessarily a problem the first time it happens. If you do see it becoming a recurring issue, it is something that you're going to want to contact OVP service about so that we can take a look at it or diagnose it remotely with you. So just keep that in mind. You don't want to just get in the habit of just popping the breaker on over and over again and not let anyone know about it. So that is fuses and circuit breakers in a nutshell. Now, if you are in the middle of troubleshooting specifically 120 volt circuits, you'll also want to check any of the GFCI protected outlets in the van as well. These GFCI outlets protect strings of outlets throughout the van. And if for whatever reason you don't see this little green light on that GFCI circuit, then you'll want to make sure that you hit the reset button and make sure that this GFCI is powered on. Now, your inverter does have to be on in order for you to see that green light. If your inverter's on, the green light is on, you should be good to go. If you're still having some issues with 110 and 120 volt after checking all the breakers, making sure that the inverter is on and making sure that the GFCI outlets are all reset, then you'll want to contact OVP service as well. That's pretty much circuit breakers in a nutshell for your DC loads and your 120 volt circuit breakers for your AC loads. There are more additional circuit breakers inside of the cabinet we're going to cover in the next section of this video. Other circuit breakers that you can always check if certain appliances aren't working in your rig are these 285 series thermal circuit breakers. Typically, they're going to be circuit breakers that are meant for your solar, your air conditioner, your aftermarket stereo installations, or pretty much any large DC powered load. They'll all typically be labeled. Once again, this cabinet is still under construction, so we are actually going to put some labels on these here in the future. You'll find that yours will be labeled. You can always tell if a breaker is popped if you see this yellow bar pulled out at an angle like this. To reset it, you'll just go ahead and pull that lever in until you hear a click. If that lever doesn't want to stay in, it's probably a deeper issue that you'll want to contact OVP about. But for the most part, it should just click right back in, and you can test that specific appliance out again. Okay, so for the low box electrical systems or plumbing systems, the layout and where the electrical components live in a rig is going to be slightly different. But I just wanted to kind of take this opportunity to show you the two different types of systems that you'll see depending on what you ordered from OVP. There's also two different battery installations that you're going to receive. In the previous section of the video, we were looking at a system with Victron batteries installed. And in this video, we're going to cover a system with Lithionics batteries installed. And really the only difference between the two different battery installations are that the Lithionics batteries utilize internal battery heaters, and the Victron uses external battery heaters that are controlled through a separate part of the system. That's less important than the knowledge that the Lithionics batteries have their own built-in backup power supply on the inside of the batteries, and they have their own shutoff switches. So when the batteries are in normal operation, if they are on and they are not receiving a charge, they'll actually have a solid blue halo illuminating this push button here. Whenever they are receiving a charge, they'll be flashing. So if you're ever under the assumption that you think that you might be having some charging issues, one of the best ways to get a visual indicator that your batteries are indeed accepting a charge is the flashing light on top of each battery. And I'm plugged into shore power right now, so that means I should be getting a charge. And looking at each one of these batteries, all three of them are flashing, so that's good. That means all three of them are getting a charge. Now, I can manually turn each one of these batteries on and off by holding the power button for an extended period of time, and that will kick them off. You can also reset them with a quick press. Now, the other part of this button and the importance of this button is that if the system ever shuts down due to low voltage, the batteries are the first thing to tell the rest of the system that they're going to be shutting down in the Lithionics case. So if everything in your van shuts off, you can come back here into the cabinet, open the lid up, and take a look at each individual battery. If all of their lights are off, they have a backup power supply on the inside of them, and you can press the button once on each individual battery, and it'll kick the system back online. And that's your reserve 10%. And so it's a good idea to immediately plug in to shore power, turn your alternator on, or if you have good solar input, you can rely on that. It's not recommended. It's better to use shore power or alternator charging to recover a battery that is low. But in both cases, it is nice to have kind of that backup supply built in to your hardware, not just the software. So when you see on your Victron screen displaying your battery percentage, it will show, 10, 5. When it's getting down to close to 0, the system will shut off. You still have a reserve 10% in these batteries. So you can come back here, kick them on, and then you'll have a little bit of extra power to get you back on the road. So that's a helpful differentiation between the two different types of systems. We already talked about circuit breakers in a previous section of our video. The 285 series circuit breakers are actually in a different location on the low box installs, but they operate the same way that we showed you in the high box installations. And then lastly, the one thing that we want to cover is the alternator regulator. It is this white box here. On the older versions, it'll be a black box, but is the WS500 or the Wakespeed WS500 alternator regulator. And it will have a flashing LED light on it when it is in current, when it's operating. And that LED is going to tell you a lot of different things based off of the color of the LEDs that you're seeing. For most installations, you're going to have a white box. If you have a slightly older OVP van, you may have a black box, but they'll both be labeled WS500. This is the charge controller and the regulator for the alternator installs, the secondary alternator installs to be specific. And if you're having issues with alternator charging, the LED light status on this regulator can give you a lot of information about what's going on. So if you're thinking that your alternator charging might not be working, you can open this box up, make sure the engine is running, and watch this LED light. Now, during normal operation, you will see a green flash when it first starts up. And then once the batteries kind of take over and they slave the regulator, this light will turn orange. And that is the case on both Lithionic systems and Victron battery systems. So once this starts flashing orange, that's the regulator telling the alternator to go ahead and start running and building a field. And if it runs into any errors along the way, what it'll do is it'll start red flashing. And you'll see 4 very fast red flashes followed by a series of slower flashes. Now, getting a video of that, or at least counting the flashes, will tell you exactly what the error code is. So you'd see 4 quick flashes followed by maybe 4 slow flashes and then 3 slow flashes. That would indicate an error code 43. Having that information ready is extremely helpful for us. And it is something that you can easily do at home and look up online to what some of the potential solutions might be. Some of them are really simple. In the configuration guide, for example, that error code 43 would indicate a fuse that is blown. Now, those fuses are located in a couple different spots depending on your installation. But if you have that knowledge, then it's a lot easier to maybe do a fix on the road. And OVP is more than happy to walk you through it. So that's a little bit more about the regulator and how it works. If you're not seeing any power to the regulator at all, that means that it's not getting its ignition sense power being sent to it, which is a fuse located underneath the driver's seat of every single vehicle, every vehicle that we install a secondary alternator on, that is. And you can find that fuse labeled underneath the driver's seat base in the OEM Mercedes fuse panel area. So at the front of the van in the OEM fuse box, you'll see this aftermarket fuse that we have in here. It's actually piggybacking off the Mercedes fuse. The Mercedes fuses have solid white lettering, and the OVP fuses that we add in actually have clear lettering, so that's how you tell the difference between the two. So this fuse looks good, so we can plug this back in where we found it, right here in position 24, and we know for a fact that that fuse is good and that our alternator should be getting power. So if you're getting no LED at all, that's the first place you can look. And if you do find that that automotive blade fuse is blown, that's usually the first thing to let you know that that's the reason why your alternator isn't working. So those are a couple of quick tips and tricks and troubleshooting advice on the regulator. Once again, if you're having any trouble with that, feel free to give us a call. We're more than happy to help.